Well, hello and welcome to chapter 4. This chapter is about network access, and we'll spend about 15 to 20 minutes on part 1, then another 15 to 20 minutes in part 2. Then part 3, we'll do a little demo using Packet Tracer. What we will cover in this chapter, or what we'll try to explain is in chapter, is first the physical layer, a little understanding what happened at the physical layer, the OSI model. Uh, we will identify device connectivity options. We're going to look at the physical layer. We're going to look at different type of cables, different type of connectors, speed, advantages, disadvantages. Then next, we're going to go into the network media. We're going to talk about what is the function of a network media, and how to choose a better network media, and we will identify the basic characteristics of cabling, like different type of cable, Cat3, Cat5, Cat6, and so forth. We will spend pretty good time talking about a little bit about UTP and STP, and when we use UTP, when we use the STP, and the most common type of cable that are used in modern network. We'll talk about fiber optics. Where do we use fiber optics? How we use it, and what are the advantages and the disadvantages? And finally, we'll talk about connecting devices using both wired and wireless media, and that what we're going to do a little lab together. All right. So without further ado, physical layer protocols. Physical layer protocols, it's first of all, in order for anybody to build a small network that allow two devices to talk with each other. In addition to the computer, you have to have some kind of a media that allow those two devices to talk with each other. Yes, you can go as simple as just a single crossover wire to computer and they will connect just fine. You can also use wireless instead of using any kind of wired. So the two most common type of media, physical media we use in a network, is basically using wired and also using wireless. In here, like I said before, network communication, you really have to use some kind of cables, and like I say, you can use either wired or wireless if you want to allow two devices to communicate with each other. How do we connect computers? Well, first of all, you need to have some kind of, if you want to connect a computer using a wide network, let's pretend that you have two computers and you have a small switch, then or an access point if you want. And you want those two devices to physically, not wirelessly, physically talk with each other. Well, you need to run what do you call it, a UTP cable or some kind of twisted pair cable from your NIC card. This is known as your NIC card on the computer. Every single computer uses a NIC card to communicate with other computers. NIC cards stand for network interface devices. And then you drag that cable, as we're going to do in the demo, to the switch, and you do the same thing for the other computers. That's one way of connecting them. You can also use wireless instead. You will have one laptop, one desktop using its wireless NIC card instead, right? And the other laptop using its wireless, and they'll connect to this access point and talk to each other. And by the way, you can also have two laptops directly talking to each other without using a wireless access point, but using wireless, and they can also talk to each other. There is two types of wireless, if you want. There is an infrastructure where you involve an access point, and there is ad hoc when there is no access point involved in the process. It is crucial and it's very important to remember this process that we covered before. Again, this is the OSI model, and you can see the layer application all the way down to the physical layer. We're starting at layer 7 and you keep going all the way down to layer 1, which is the physical layer. And you could see, like we did before, we talked about process known as encapsulation, de-encapsulations. And I'm sure you remember that each layer of the OSI model, that data becomes something else, right? At one point it is a segment, another point it becomes a packet, another layer becomes a frame, then it becomes a bit. But what happened to it at, what do you call it, at the physical layer? At the physical layer, the bits are converted into some type of signals, and that is the job of the physical layer, is to take the bits, the ones and zero, and convert them into signal and put them in the wire. All right. The different type of media layer that what we call it, network layer or the physical layer, can take any binary chunk and convert it. There are three basic media forms. One that is electrical pulses, like you see over here. It's used usually when you're using copper. Then there's light, right? And usually when you're using fiber optics, right? And there's all the way down microwaves, and this is when we're using and you're using what you call it, you're using Wi-Fi. So it is really extremely important to understand it is the physical layer that takes the binary number at the last stage and convert them either to electrical, light, or microwave. So what defines what format will be used? It's what kind of NIC card are you using and what kind of connection do you have. If you're using UTP, obviously your NIC card will convert it into electrical pulses. And if you're using fiber optics, obviously it will turn into light. And if you're using Wi-Fi, it's some kind of microwave, some kind of wireless. Whenever we talk about the physical layer, some of the characteristics that you need to know, there are a lot of them, but not my purpose not to overwhelm you and send you everything at one time. But what I want you to understand is really when you are choosing what medium would I use, usually the capacity and the bandwidth define. Another way, how much data I can send from point A to point B at exactly the same time. Now that bandwidth can be measured. Usually it's per second, right? It's per second, and it could be kilobit per second. It could be bit per second, kilobit per second, megabit per second. And this is, by the way, when you are home, megabit. And trust me, it's not a megabyte. It's a megabit per second. Megabyte is capital B, right? And megabyte is used as a unit that we use in RAM, in memory, and so forth. Gigabits and also terabit if you want. So the most common use today that I know for sure, like your home, if you know what speed you have, just go to fast.com and you'll be able to see how fast is your bandwidth using megabit per second. All right, now network medias. The different type of cable that you may see in modern network. I'm going to start from the bottom. The coax cable, we don't see it really quite often, although years ago it used to be really the primary, the only one type of cable that we used back then. But I don't see it quite often anymore. The two most common type of cable, the three as a matter of fact, there's another one will come in soon. There's the twisted pair. So the twisted pair is the most common. So you can see we have here, this cable are the same. The only difference between them, one is unshielded, has no protection. This is the shield, right? This is shield, and one is protected. Is using called STP. So we have UTP and STP, and the difference between them this. And if the reason why we use this shield is to protect the cable against interference and against EMI. So this is much better, and I'm sure if I say much better, you may think this is the most common used type of protocol. The truth, it's not. This is the most common used one. This is a little expensive, hard to work with. We use it only in certain cases, but almost 90% of the time you'll be using this. The other cable that is not here is fiber optics. All right, so here's certain type of UTP, unshielded twisted pair. There's Cat3. They're all we put them by categories. There's Cat3 and there's Cat5. There's no Cat4. Which what would never implemented. Cat3, Cat5, and there's Cat6, and there are also different type in Cat6 and Cat5. For instance, you can see Cat3, by the way, is used for phone, and Cat5, Cat6 are used for networks. And you can see here what I want to point out. There's Cat5 and Cat5e, and all this E stand for usually is enhanced. So you may be better in something, maybe faster, or new technology has been embedded in it, all right? Or or we called the length, how far can it really go. Here's a Cat 6 over here, and you can see Cat 6 is used for data transmission that we talked about and allowing to function at higher speed, and you can see that can support 100 megabit per second up to 10 gigabit per second. So, and there's also 6E, and they keep coming up with new categories. Whenever you have a cable, one of the most important things, especially if you're making cables, I don't advise you to really invest time and money in learning how to make cable. It is very difficult, and yet a company maybe pay a lot of money for you to make a cable that somebody can make with a cable that you can buy from China probably for $5. All right. So I do not advise my students to really make their own cables. You can buy cables. A reason why there are a lot of requirements and it's time consuming. And however, if you want to play with it and you want to make it, sure you can play with it and do it. So when you are making cable, this is the different type of connector that that we usually use. This is what we call RJ45, and this is the header, right? It's very similar to your phone, but the phone uses RJ11. This is RJ45, bigger than your phone. In here, this is an RJ45 UTP socket. Is another simple way of making cable. Like you just push the cable down here, right? And here it is. And by the way, there are two, as we're going to see, this RJ45 is using this standard. When we are making cables, we need to pick and choose a standard or a pin out. There is a 568A and there's a 568B, and we're going to see that once we move into cables. All right, so here's what I just said. That you can see here, there's T568A, all right, and there's a T568B. Again, what's this? If you are making a cable yourself, you either need to follow this standard or this standard. And by the way, you need to follow the standard at both ends of the cable. You can't have one end here and have completely different end over there. And even more, in your network, you should not really have a mixed type of what you call it of standard. You should stick to one type of cable. And I tell you, in the US, the most commonly used cable in a network that I saw is 568B. If you look at the cables over here, here they are really in order. Nothing is being changed. But here you can see here that what do you call it? Stripe orange, and look what happened. Stripe green, and we have separated the green. You see, we separated the green, then we put the blue inside, but we twisted. That what you call it. We changed the order of the cables. We usually start with the stripe, but in the blue, we start with the solid instead. And the rule here, we say, separate the green and reverse the blues. I will repeat, separate the green and reverse the blues. All right. This here's our fiber optics. I doubt you've been making fiber optics cables. You have to be an electrician. You have to be certified in low voltage in order. Fiber optics, unlike TP and UTP, have different type of connectors. And the different type of connectors usually depend what type of cable, what type of fiber optic that you're using. For instance, there is something known as straight tip ST connectors. We have subscribe connectors. We have LC connectors, and we have duplex multi-mode LC connectors. So we're talking about the connectors over here. Fiber optics, as you're going to see, always two cables are being used. One cable is used to send, another cable to use is used to, what do you call it? And it is used to receive the signals. Whenever you compare the difference between UTP and fiber optics in what do you call it? UTP and fiber optics in a network, you'll quickly find out that definitely there's some advantages of using fiber optics. But you can't use fiber optics all the time. In a network, I've seen both of them used. But I just want to point out to something very important. For instance, in the bandwidth support, the UTP support up to 10 gigabit per second. And watch over here, the fiber optic can support up to 100 gigabit per second. Distance, UTP, you have 100 meter or 350 feet. I think 350 feet, while while fiber optic can support up to thousand meters. Immunity to electrical hazards, especially the EMI. You can see that UTP is very low, but fiber optic is very high. Media control costs, obviously, fiber optics is more expensive than you call it. Safety precaution is very low when you're dealing with UTP, but with fiber optic is very high. I do have a personal experience with an injury from fiber optics when I looked at it as I was putting it, and the light went straight into my eyes, and needless to tell you, the rest. Besides using cable, like I said, we can use Wi-Fi to connect to devices, and we have a different standard of Wi-Fi over there. We have 82.11, and this is the Wi-Fi that you guys use in home. All right. We have also 82.15, and this is what we do about the Bluetooth, also known as wireless personal area network, like the case where you connect your watch to your phone using Bluetooth, or if you have any Bluetooth speakers and you connect it to your phone, that's also using Bluetooth. Hence, that's why I call it PAN, Personal Area Network, and it's very limited in the distance, as you may see over here. WiMAX, something that we have been trying and thinking to do and implement and take to the next level. You've seen it. It's out there, but it's not what it's supposed to be. It's an old technology, but yet it's have not reached what do you call it, its goal, if you want to. All right, so I'm gonna stop here and I'll come back and talk a little bit more about wireless in the next in part two. All right, I'm gonna stop